So in this class, I'm going to explain about is a transform of digital processing. So is a transform definition first of all. So in the your prior classes already you studied about Fourier transform and Laplace transform. So what is the difference between Laplace transform and is a transform? So in a Laplace transform, so you are going to studied about the continuous time signal, but here we are going to study about the discrete time signal in a transform. In a generalization of the Fourier transform, it does not exist for all signal. So the Fourier transform exhibit only for the limited signal. So that's why we are moving into the Z transform rather than this Laplace transform and the Fourier transform. The Z transform of a set of sequence x of n is defined as Z of x of n equivalent to summation of n is equal to minus infinity to plus infinity x of n z power minus n, be represented as x of z. So this is the sequence expression for Z transform. If you go for inverse Z transform, so we are having x of n. So the previous case we discussed about z of x of n. Now we are going to x of n. So this z comes into here, z inverse. So z inverse of x of z will be a output. So x of n is nothing but 1 by 2 pi j, the counter integral of x of z power n minus 1 dz. So this expression denotes a closed counter integral taken as counterclockwise about the origin and in the region of convergence. So here we are going to discuss about the region of convergence, whether your system is converged or not for the particular region. It incorporates the Cauchy integral theorem from the theory of complex variable. So this result is not given directly in Hopkinian, but may be found in Pro case. Then relationship to Fourier transform. So Z transform of a sequence x of n is defined as x of z is nothing but summation of n is equal to minus infinity to plus infinity x of n z power minus n. From the Fourier transform of sequence x of n is defined as x of e power j omega, which is equivalent to n equal to minus infinity to plus infinity x of n z power minus j omega n, where z is nothing but e power j omega. The z transform reduces the Fourier transform. So this domain is a circle of unit radius in a complex plane, that is z equal to 1. So we are going to draw a unit circle over the xy plane. Then convergence of this transform. So DTFT, discrete time Fourier transform, does not always converge. So x of e power j omega is nothing but summation of minus infinity to plus infinity x of n e power minus j omega n. Infinite sum not always finite. So if x of n is no absolute summable. Example, x of n is nothing but a power u of n. For all a is greater than 1, so does not have dt of t. So this infinite pattern dt of t does not always converge. So we go for the z transform. So complex variable z can be written as r e power j omega. So the z transform x of r e power j omega is nothing but summation of n equal to minus infinity to plus infinity x of n. Instead of this z, we represented r e power j omega whole power n. So z power minus n, we represented r e power j omega power minus n. So again, n is equal to minus infinity to plus infinity x of n r to the power minus n into e power minus j omega n. So dt of t of x of n multiplied with the exponential sequence of r of n, r of minus n, for certain choices, or the sum may be made finite. So we can write n is nothing but minus infinity plus infinity in a summation x of n r power minus n always less than infinite. So what is unit circle in complex Lasser plane? So the Z transform is a function of complex Z variable. So convenient to describe the complex Z plane. If you plot Z is nothing but e power j omega for omega equal to 0 to 2 pi, we get unit circle. If you substitute omega equal to 0, it is equal to 0, Z is nothing but 1. Any value. So the certain of criterion for conversion is that Z transform be absolutely summable. So this is the first criteria. Example, summation of minus infinity to plus infinity, modulus of x of n, Z to the power minus n, always less than infinity. If some value of Z, say Z equal to Z1, is in the ROC, then all the values of Z in a circle defined by Z modulus of Z is Z1 will also be ROC. So the ROC will be consist in a ring in the Z plane centered about the origin. In outer boundary will be a circle and inner boundary will be a circle. It will be based on the ROC may extended the outward to infinity or extended towards the origin. So this is a very important thing. So whether ROC is extended outward to infinity or towards the origin, it depends upon the modulus of Z value. So this is the given. So R1 outer radius, R2 is inner radius. So this is the unit circle given. So the region of convergence as the ring in the Z plane. For specific cases, the inner boundary can extend inward to the origin, or ROC becomes a disk, or in other cases, the outer boundary can extend outwards to the infinity. So it is based upon the situation, we can conclude that where the ROC or region of convergence will be existing. So this is Lorentz series. X of Z is nothing but summation of n is equal to minus infinity to plus infinity. X of n is to the power minus n. A power series of this form is a Lorentz series form. A Lorentz series and therefore Z transform represent the analytical function at every point where the region of convergence. So this means that the Z transform and all its derivative must be continuous function of Z within the ROC region. So within the ROC region only, then it should be a continuous form. It should be maintained. So x of Z is nothing but P of Z by Q of Z. So among the most useful Z transform and those for which x of Z is a rational function inside the region of convergence. For example, where P of Z and Q of Z are polynomial, the values of Z for which x of Z are zeros and the zeros of x of Z, and the values which x of Z is infinite are the poles of x of Z. So normally we know that zeros and the poles are located in the transfer function model. So zeros is represented by how many number of Z is multiplied with the numerator, or it will be notated in the origin function. That is called poles. Zeros, that is called zeros. The poles represent number of the polynomials will be represented in the equation. So the properties of the ROC. So ROC is a ring or disk in the Z plane centered at the origin. So either we consider as a ring or the disk form. So if you consider this, then 0 is less than or less than or equal to r, or less than modulus of Z, or less than or equal to L, less than or equal to infinity. So R and L represents the left and right of the XY plane. The Fourier transform of x of n converges absolutely if and only if ROC of the Z transform of x of n includes a unit circle. So the ROC cannot contain any poles. So it doesn't have any poles. If x of n is a finite duration sequence, the ROC is the entire Z plane except possibility of 0 to infinity. So the sequence is finite sequence, then definitely the ROC is entire Z plane except the possibility of either 0 or infinity. Okay. If x of n is the right-handed sequence, then ROC extend outwards from the outermost finite pole in x of z to and the possibility including infinity. If x of n is a left-handed sequence, 0 for n is greater than n2, then ROC extend inward from the innermost non-zero pole in x of z and to 0. A two-sided sequence is infinite duration sequence, that is neither right-handed or left-handed. If x of n is two-sided sequence, then ROC will consist of a ring in Z plane bounded on the interior and exterior by a pole and consistent with the property of 3 not containing any poles. The ROC must be a connected region. So this is the property of ROC shown graphically. This is a causal, anti-causal and two-sided system. The entire Z plane except Z0, entire Z plane except to infinity, entire Z plane except to Z equal to 0 and Z equal to infinity. Okay. So this is a causal system which is represented in the right handed of the sequence. So except to 0, the arrows will be there. Anti-causal system, the discrete time sequences are represented in the left hand of is a XY plane. So that is infinity. If it is a two-sided sequence, then the entire Z plane must be except 0 and infinity. Okay. Then infinite duration. This is a finite duration signal. If suppose your signal is infinite duration signal for causal system, your system is a discrete system represented in the right hand of XY plane. That is modulus of Z is greater than R2. So the outermost circle will be a ROC, then inner side there will be no ROC. For the case of anti-causal system for infinite duration signal, your modulus of Z is less than R1. So your ROC should be the inner side of the circle, then outermost there will be no ROC. If suppose a two-sided system, then R2 is less than of modulus Z and less than of R1, then your ROC must be there between R1 and R2. So this portion only shaded by for marking the ROC. So for example of right-handed sequence, so x of n is nothing but a power n into u of n. So x of z is nothing but summation of n is equal to minus infinity to plus infinity x of n into z power minus n. So x of z is nothing but summation of n is equal to infinity a z power minus 1 whole to the power n. So if you rearrange the expression, substitute n equal to 0, a z power 0 plus a z power 1 plus a z power 2, etc. So 1 plus 1 by if suppose n equal to 0 means a to the power 0 1 plus x to the power 2 plus x to the power 2, so etc. So the sequence we can write in the shortage formula 1 divided by 1 minus a or x. So 1 divided by 1 minus x is nothing but a z power minus 1. So the ROC compulsory fit into 1 minus a z power minus 1. Otherwise, a z power minus 1 is lesser than of 1. Otherwise, we can write modulus of Z is greater than A. So your unit circle is represented in the darker line. Your A must be represented by below the unit circle here point. So your ROC is compulsory fitted in between this A and behind it to infinity. If suppose your sequence is this is same sequence, will be a left-sided sequence. So see, so here you have the output of mod Z is greater than A. Similarly here mod Z is less than A. So mod Z is less than A means, so you have a unit circle 1, then the A represented here. So the convergence region will be lesser than A. So this portion will be shaded. Okay. This is the difference between a right-handed sequence and a left-handed sequence. Again, if you go with the sum of two exponential sequence means, so see here x of n 1 by 2 whole power n u of n and minus 1 by 3 of whole power n into u of n. So this is of A 1 by 2. So right-handed sequence 1 by 2, and after that you have ROC here minus 1 by 3, the same sequence, but in the left hand side, this is the right hand side minus 1 by 3 and that sequence. Okay, so this is your final pattern minus 1 by 3 to plus 1 by 2. You have the poles are marked, then ROC will be fitted in the outer side region only. There will be no inner side in ROC. The poles at 1 by 2 and minus 1 by 3 and the zeros at 0 and 1 by 12. Then for the case of two-sided sequence, see, so the ROC lies between 1 by 3 and 1 by 2. If you substituted this, mod Z is greater than 1 by 3 and here mod Z is less than 1 by 2. So your ROC located in 1 by 3 to 1 by 2. This is 1 by 3 and this is 1 by 2. So between the place we have ROC. So then this steps goes on finite length sequence. So 15th order pole x of n is equal to a power n. So x of z is nothing but 0 to n minus 1 a z power minus 1 whole power n. So rearrange it. Then ROC is modulus of a less than infinity and z is not equal to 0. So in that case, so your ROC represented here modulus of a is less than infinity. So this is represented. So this is an example for left-handed sequence. Right side, left side, then so two side and two sides. So these are the explanation for ROC. Then common Z transform pairs. So if your sequence is del of n, the output of transform is 1. So all Z is under ROC. Sequence is u of n, unity function, 1 divided by 1 minus Z power minus 1. So modulus of Z is always greater than 1. So the function of ROC is greater than 1. So minus u of minus n minus 1, which is 1 by 1 minus Z minus 1. So modulus of Z is lesser than 1. So you have a unit circle. So below the unit circle you have ROC. But in the previous case, above the unit circle you have ROC. So like this, all the properties will be explained. So thank you for watching.